So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 346 and in this video we continue with our move constructor, and like all time here in CPP reference com language, here to move constructor, here down the examples we have covered a little bit. Okay, and I'm using again the compiler explorer and we are here on line 80, and I wanted to make here a side note. This std, what I call std, they call in general std. So I call it from now on also std because everybody is calling like that. So what we have here is a std cout, which means just we print something out. This is the line here trying to move C. Okay. Then again, we are creating a new object like before here with B1. Now we are creating C1 and we have a class or a type C. We jump to see what it is and we see it is again a struct. And we see it is again inheriting, but this time not from the base object what we have here. It is inheriting from B, which is inheriting from EA. And the only thing what we have now here in the struct, we can read it, is just a destructor of the C. And when we read here the comment, we see one more thing. Destructor prevents implicit move constructor. So you have all time to keep in mind that the move constructor is not all time implicitly created when the requirements are not met. For example, here we have this destructor, so the requirements are not met and the compiler is not creating now the move constructor. And here the other example was B. Here the requirements are met and the compiler will create this implicit move constructor. And in our last example with B1, we saw when the move constructor is created and we are trying to move it from B1 to B2, we saw that the move worked with inheritance. Okay, let's follow the build creation here, line 81. C1 we create C1. So what happens? We go to C. And C, there is nothing, but keep in mind there is something. And the build order is like it jumps to B because it inherits from B, and B jumps to A because B is inheriting from A. And in A, the constructor is called. Okay, where is the constructor? So the constructor is here because we are constructing an object. And the constructor will assign now test to S and K to -1. This is the first step and we can see this here. Okay, now we jump again back to the next line, which is 82. And again, you see this is very familiar to the line before, which we discussed in the other video. And we do exactly the same thing. We're using again std move, which is just a cast because C1 is again L value. We convert it to an R value, and when we convert it to an R value, we can use move constructors. Actually, that means not really we can use move constructors. This means only we can bind to an R value, and move constructors bind to R values normally. In this case, we see when we jump to C, we can't use move constructors because this one here will not create an implicit move constructor by the compiler because the requirements are not met. Okay, let's see what happens. We are in line 82. We have this std move C1. Okay, we have created an R value. Now we try to create an object C2, which is C. Then we jump to C and the compiler will first check what it can do, and the compiler realized, oh, here's a destructor, I can't provide a move constructor. So the compiler says I can only use here the copy constructor. Then the compiler says in the next step, oh, struct C is inheriting from B. Okay, in this step, the compiler says here I can provide a copy constructor and a move constructor, but I will use the copy constructor because here this one can only call the copy constructor. Okay, then here it is using also the copy constructor and then it jumps here to A because it is inheriting from A, and it sees here is anyway a copy constructor for user defined provided and a move constructor as well from the user, and it will use the copy constructor because it was called here with the copy constructor again. And here are important side note, careful. I said we start from C and then we go to A and then we go to the base struct A, right? This is not the build order. What I mean with that, this is not the build order, because the compiler start all time from base, create this one first, then it creates the inherited version. In this case, it would create struct B later, and then it creates struct C. But the question is then, if it would start from A, how does the compiler know that here in C it can't create a move constructor? The short answer is there is a compile time check by the compiler, which means it checks just this one briefly, what constructor is available. It checks the same thing here, and later it starts then from here. That's why the compiler will call now here the copy constructor, and we can see this here on the sideline with copy constructor A called move failed. So this one is the thing what is called first. Again, later B and C is constructed, but the compiler has checked this in compile time the other way around. That's why it is constructing here at start just this copy constructor. And we can jump to the next example here as well. Again, we have here std out. We are trying to move D. This is this line here. And now again, we create a new object called D1, but this time with D, we check what D is. D is here again a struct. Important, it inherits from B, not C. That means we are inheriting from this one, and we know struct B can create a move constructor and a copy constructor. Good. And here we check now what happens in D. We see we have here a normal constructor. Okay. We have here a destructor. We just learned when we provide a destructor, the implicit move constructor by the compiler is not created. Okay. But the next line is a user provided default constructor, which means you can see here now, because we are provided a move constructor as default, then the compiler can create a move constructor anyway. Again, a short repetition. When you see a destructor, the compiler is not creating normally a move constructor. And if this is happening, then you have to provide a move constructor, or if you want use the optimization of the compiler, you can make that what they have made here. They defaulted the move constructor, and then the compiler can use the move constructor again. Even this requirement is broken with this one here. So you can see this is a requirement, and this one is changing this requirement again. And here a side note, because these requirements are annoying to remember and sometimes you don't know what happens, therefore they use the simplified rule versions. You heard of them: rule of 0, rule of 3, rule of 5, and we will talk about them also in another video. But we jump to the next line, which is 86, and again we do almost the same thing what we all time do. We try to create a new object. It's called D2 with the struct D. Again, we have here std move. We are converting D1, which is an L value, to an R value. So with an R value, we can bind to a move constructor if it's possible. And we check again D. If this is possible, we jump to D. This time it is possible with this one here. Even we have this one, because this one is allowing us again. Then the compiler checks again. What happens here? Okay, struct D is inheriting from B. We jump to B. B can create a move constructor and a copy constructor, but we have used here already the move constructor. The compiler says, okay, I will use here also the move constructor. And then it checks, oh, B is inheriting from A. And again, A is checked, and the compiler says, okay, here is a user-defined copy constructor provided, a user-defined move constructor provided. I use the move constructor here as well. Okay, so what happens then? We know that the object down here, D1, was created with the constructor, that we can see this here, constructor A call. So we go there. And we know constructor A is just assigning here the value test to S and -1 to K. Okay, and now we also know the move constructor will be called here when we try to use this one and create D2. So again, the compiler will just use that what we already learned, and we know then here the output. D1S, again, we are down here. D1 is this one here, not D2. Again, we should watch this one here, what happens with the value from the source. And it is again, in this case, empty, because the move constructor just moved, take the resources from D1 and let D1 itself in a valid state, which means after taking the resources, I still can assign to D1 anything, but careful, don't use D1 or don't expect that D1 has the old values. So, and with that said, we finished this video here, and like all time, if you have any questions, write in the comment section. See you in the next video. Bye and good luck.